This glowing server rack represents what enterprise investment looks like today. Billions of dollars in capital are currently being forced into foundation models, AI copilots, and multi-agent systems. Technology vendors project massive outcomes. They promise exponential productivity gains and autonomous execution capabilities designed to move work through a system with zero human friction. But look at the reality on the ground. Enterprise AI pilots are multiplying rapidly across departments, yet core operational performance metrics remain completely flat. At the employee level, the symptom is clear. Knowledge workers spend significantly more time experimenting with these new applications than they do improving actual business outcomes. This leaves chief technology officers facing a critical tension. Are we looking at a genuine shift in how work moves through an organization, or is this just another technology cycle bloated with inflated expectations? The massive financial investment is failing to translate into operational throughput for a specific reason. The deployment strategy is broken at the architectural level. The root cause of this failure is a pervasive misconception. It is the mistaken belief that dropping a superior technological tool into an existing workflow automatically generates superior work. Enterprise architecture relies on a strict rule. No technology can be designed in isolation. Every decision must strictly support a predefined operating model and production system. When overly complex tools are force-dropped into a functional system, the pathways instantly clog. Because artificial intelligence can be applied to almost any task, this architectural discipline becomes the primary safeguard against systemic waste. This suggests that productivity might not be determined by the sophistication of the AI, but by how well the technology reinforces the underlying logic of the work. We can see this clearly in manufacturing history. No single production model is universally superior. Job shop, mass production, and continuous process systems each optimize for entirely different objectives. Modern knowledge work operates under the exact same constraints. Enterprise operations are deeply heterogeneous. Software engineering faces different requirements than regulatory compliance or customer service. This diagram highlights the problem. Applying a single, generalized enterprise AI platform across these diverse departments is a severe architectural failure. The monolith immediately conflicts with the unique constraints of each distinct workflow. To correct this, enterprise architects must rigorously map the architecture of the work before even considering the architecture of the AI. This starts by mapping critical variables. First, is the target workflow highly standardized, or does it require high degrees of creativity? Next, what is the primary objective of this specific system? Are we optimizing for speed, quality, innovation, consistency, or strict regulatory compliance? Finally, we have to ask the ultimate governance question. Where in this specific system must human accountability remain absolute? Selecting an appropriate AI capability is mathematically impossible without first understanding the specific limitations and requirements of the target production system. This brings us to what we call the parameter trap. This is the flawed enterprise instinct to assume that larger, more sophisticated foundation models automatically yield better business results. Teams fall into this trap constantly. They compare parameter counts, context windows, and benchmark scores, while entirely overlooking adaptability to the actual workflow. We have seen this before. Military and industrial history show a consistent pattern of failure when organizations prioritize sheer size and complexity over systemic agility. Purchasing increasingly sophisticated machinery without redesigning the work itself is a mistake the AI industry is currently repeating at scale. Deploying the largest available foundation model often introduces unnecessary system constraints and friction, rather than solving existing business problems. The corrective principle that cuts through the hype is simple. Architects must ask, what is the absolute lightest, least complex AI capability that can effectively solve the identified business constraint? For example, a targeted document summarization model outperforms a massive general-purpose model for routing correspondence. A simple retrieval augmented assistant seamlessly handles it. Similarly, rules-based workflows enhanced by narrow AI achieve higher reliability for regulatory tasks, reinforcing rigor without overrouting it. A simple retrieval augmented assistant will almost always deliver greater, faster business value than an end-to-end autonomous process that requires massive human oversight. True architectural excellence in the AI era is measured entirely by fitness for purpose. It prioritizes exact system alignment over technological ambition. Viewing AI as a monolithic upgrade leads to critical design errors. Technology extends human capability through three distinctly different vectors. The first vector is mechanization. This is an architectural pattern whose primary historical purpose is to improve the raw speed of human execution. The second vector is automation, an architectural pattern designed to entirely remove repetitive physical or digital effort from the system. The third vector is AI augmentation. This is a novel architectural pattern whose explicit purpose is to accelerate analysis, reduce cognitive burden, and improve human judgment. Failing to intentionally distinguish between these three vectors inevitably leads to warping enterprise work, rather than selecting the precise tool that serves the desired business outcome. When this foundational rule is inverted, and the work begins serving the AI platform instead of the AI serving the work, the enterprise environment becomes chaotic. We call this symptom information bloat. Teams generate massive volumes of AI-created reports, meeting summaries, and slide decks because the tool makes it frictionless. The paradox is that enterprise documents become vastly longer without becoming more valuable. Dashboards become visually richer without actually improving executive decisions. This is a critical system failure. The AI platform is now generating content significantly faster than the human nodes in the organization can possibly consume or act upon it. Leadership often falls into a financial trap here. They attempt to justify the massive cost of enterprise AI platforms by maximizing tool utilization, essentially paying algorithms to create low-value noise. Allowing expensive computing capacity to sit completely idle is financially and operationally superior to allowing it to continuously generate unnecessary work. An overutilized, misaligned AI tool that is disconnected from concrete business outcomes actively degrades organizational insight and paralyzes decision-making. There is a counterintuitive truth in the modern enterprise. The most valuable AI system is very often the one that quietly eliminates unnecessary tasks, rather than the one generating new outputs. The absolute highest responsibility of enterprise architecture in this new era is aggressively preserving organizational simplicity amidst an overwhelming abundance of technological capabilities. Organizations do not become industry leaders by simply hoarding the largest collection of foundation models and autonomous agents. The ideal enterprise end state is a meticulously designed production system where every workflow remains understandable, every AI capability has a surgical purpose, and human accountability is never obscured. Ultimately, competitive advantage belongs to the organization with the simplest architecture, one that allows humans, processes, and targeted AI to produce extraordinary results together.